How many of you in your time off have been thinking about how to add fractions together? How many? None of you? Well, that's fine because I haven't been thinking about it either. In fact, what I've really been thinking about is how you would undo the adding of fractions together. In other words, how would you reverse that process? Well, to answer that question, we do need to think about how to add fractions, and we'll see if we notice any type of pattern. Now, maybe you're wondering, Ms. Naylor, what's this have to do with matrices or systems? Well, it has a lot to do with it, actually. So let's add these fractions together. And actually, it shouldn't be a big surprise that you need a common denominator. And of course, when you multiply the bottom by x plus 7, then you better multiply the top. So we got to do the same thing in our other fraction. We're going to have to multiply by what's missing, that is an x. Okay, so looks like we're kind of getting ourselves ready for getting some simplified numerators. What do we have here? 4x and 28, and of course a 3x, and we have our common denominator. So when all the dust settles, we're going to end up with a 7x and a 28, and of course that common denominator. So let me ask that question again. How many of you have been thinking about how to reverse this process? That is, if we go back to kind of where we started, how could we take our new fraction, 7x plus 28, and make it go back and equal 4 over x and 3 over x plus 7? Well, what do you think? It looks like that the denominators of our two fractions have a pretty good connection to the denominator of our one fraction. But where in the world does this 4 come from? And how about 28? Now, maybe you can see that there's some connection, but if I was just going to go straight from the beginning back to where I started, there's got to be some way to get these numerators. And it turns out that the numerators really become, or the search for the numerators really become the main task. Well, the process of finding these numerators is going to take a process known as partial fraction decomposition. Now, partial fraction decomposition sounds like a real bucket of fun, doesn't it? But it's actually a pretty neat algebraic process, and you're going to directly use it in calculus next year. You probably think I say that all the time, but I promise you will use partial fraction decomposition for a particular type of integral. Well, it's a process, and not that I am big on step 1, step 2 when we go through things, we go through concepts this year, but I do want to show you that you have to go through each of these steps. If you want to write these down, you can. I will have them up as we work through each problem. By the time we're all done, you guys will be doing these steps naturally, but I still want you to see step 1. You're going to end up setting up a partial fraction template, and that template's going to involve the factors. It's actually going to be the factors of the denominator. Now, once you get that template set up, you're going to always multiply by the common denominator. It's a little different use of the common denominator. You're going to multiply by it. There's going to be this organization that happens. And then it's one of the key steps in this process. You're going to equate the corresponding terms. Sounds pretty neat. We're going to equate the corresponding terms. And then there it is, a system. We're going to solve a system for whatever we need, whether it's A and B or maybe A, B, and C. But you'll see, the system will jump out at you. Now, the final answer is going to end up being the fractions that we're trying to create. And all that means is we're going to have to take some information and kind of plug it back in to the original template. Ready to go? All right. Let's see if we can do a partial fraction decomposition, which basically means we're going to reverse the process of what it took to get x plus 4 all over x squared minus 5x plus 6. X plus 4 all over x squared minus 5x plus 6. All right, well, the first thing we need to do is we need to set up a template, but that template is going to involve the factors. And the factors, well, what we're insinuating would be the factors of the denominator. Okay, so you're going to factor, you're going to kind of change the look of the denominator. There's a lot of factoring tools out there, but sometimes all you got to do is find two numbers that multiply to be 6 and add to be -5. Yep, -3 and -2. Now, it turns out that we would be in 100% agreement that every time you have a denominator made up of factors, that those will be the individual denominators of each of my partial fractions. And so you'll see that we're always going to take these factors, x minus 3, and the other factor, x minus 2, and we'll put them in the denominator of our partial fractions. And it's going to be the numerators that you'll discover we don't know. And we're going to just call them A and B. Okay, so really what this is a search now for A and B. Okay, so we're going to start looking, and the first thing we do is we multiply by the denominator. You see, what this really is an equation, and it's an equation that's full of denominators. But if we just multiply by the common denominator, now that means that I'm going to multiply both sides by x minus 3, x minus 2. So I'm going to multiply both sides by the common denominator. What that means is that it'll distribute here, it'll distribute here, and it'll distribute here. Now, when you get good at this, you're not going to feel like you have to write all this down. But since this is the first problem that we're doing, I'm going to write it down. So my common denominator gets distributed to my first fraction. There it is, x minus 3, x minus 2. Now, it's still all over x minus 3, x minus 2. Now, if you're saying, that's going to cancel, right? Right, that's why we did it. Okay, but I'm going to show it the first time. So I'm going to multiply x minus 3, x minus 2. By the way, do you see where this is being multiplied? Yes, that's right. It's being multiplied to the numerator. Why would I multiply it to the numerator? Because I want to cancel it with the denominator, silly. All right, so what do we got? We've got, one more time, x minus 3, x minus 2. If I have enough space here. And that's all over x minus 2. As I mentioned, when you get good at this, which is going to be soon, you're going to say these cancel, right? And you're going to say that these partially cancel. Well, in other words, it partially cancels with that common denominator, right? And then here x minus 2 cancels. And so I'm going to be fine if, when you're ready, you're comfortable just writing down the result of that multiplication. In other words, an A times just x minus 2 and a B times just an x minus 3. All right, starting to look a lot more like an equation that we can solve for A and B, isn't it? It is. That's why I believe the next step was to start to organize some things. Now, to organize some things would imply that we're going to do the distributive property. We're going to kind of start splitting up some of these expressions. And I'll tell you what, I'm going to kind of skip one step, and I'm going to say that these AX and BX that I would get from the distributive property, you want to put them right beside each other. So we're going to organize that, and then we would end up with a minus 2A and a plus, or no, we would end up with a minus 3B, right? And I'm going to go ahead and kind of put those beside each other also, which is part of the organizing. Now, you might not know why, but you will soon, that why I'm going to factor out an x. My next step is going to be to factor out an x. And that's actually part of my organizing step. And you'll find yourself factoring every time, or I should say every time that you can factor. So look what happens when I factor out an x off of a plus b. And then there's nothing to factor over here, so just let that be. All right, we're ready to do kind of my favorite step, and that is to equate the terms. Listen carefully as I ask you a very simple question. What number is in front of x on the left side of the equation? What number? 1, right? Well, what is in front of x on the right side of the equation? What's in front of x on the right side of the equation? You catch my hint? That's right, it's a plus b. Wait a minute, what has to be true if both sides of the equation are equal? What has to be true about my two gold boxes? Yes, that is right. A plus B has to equal the number 1. Now, that's because both sides of the equation are equal, so whatever's in front of x needs to be equal. Start to make up a little equation off to the side here. Now, I don't have any other x's, but I do have basically a constant. A constant is a number without a variable. Obviously, it's the number 4, but what is without a variable on the other side of the equation? That's right, it's negative 2a and minus 3b. In other words, they don't have an x with them. So what has to be true about those two blue circles? You just equated the terms. Again, those have to be equal. We just made a system, didn't we? We just made a system. And if you think about it, we're going to solve that system. That's right, we're going to solve it for A and B. And I know this is new, but remember, our goal back in the beginning was to find A and B. Getting close. Now, before you put that into a matrix, you don't need to put everything in a matrix, do you? No, you could just multiply this equation by 2. And of course, you don't get 21, but you end up with 2. And now we can add these equations together so that we can say that negative 3b is going to equal 6. Yeah, that means that b equals negative 6. And if b equals negative 6, a little bit of this and that is going to give you that a equals 7. So we just found the numerators. We just found the numerators of our template. And you're going to find out that our goal is to express these, or express the original fraction as these partial fractions. And so all I'm going to do is just fill in my two values for the numerator, write out my two fractions, and we have just performed a partial fraction decomposition. Now, it's a negative 6, so we can write that as minus 6. And so our two partial fractions are 7 over x minus 3 and minus 6 over x minus 2. Pretty neat, eh? Okay, there really wouldn't be any way to figure this out by brute force. Who's going to come up with a 7 and a negative 6 just by staring at that original problem? Well, most people would say they can't. Now, if we were in class, the next problem that I give you, I honestly would say, try it. And I'm going to say, even though we're not in class, to try it. And as you try it, I'm going to be like a step behind. Okay, so I really encourage you to not just keep watching the video, but to start thinking about how can you get that first step going. How can you take 1 over x cubed minus x squared minus 12x? How can you start to factor the denominator? Okay, and purposely I'm going to let the video keep running, and I'm going to fill in the next steps slowly but surely. Okay, ready? Go. How's the factoring going? Okay, because I normally would suggest that we first think about a little Gcf factoring. Okay, factoring doesn't always have to be like FOIL factoring. So a little Gcf factoring. Can you factor the trinomial? Can you split x squared minus x minus 12 into two binomials? You can if you use x minus 4 and x plus 3. Okay, now listen, we have 3 denominators, or I should say we have 3 factors that are going to make 3 denominators. Can you set up the template? Okay, so one of the denominators has an x, One of the denominators has an x minus 4, and one of them has an x plus 3. What goes in the numerator? How'd you do? We have 3 numerators. Okay, we're looking for A, B, and C. You should be multiplying by the common denominator. Okay, that means you're going to be multiplying the whole equation, both sides, by x, x minus 4, x plus 3. Now, as I said in the last example, as soon as you're ready, you don't need to show all this cancellation, okay? Because yes, every time it's going to fully cancel. Okay, so for this particular problem, we're actually just back to the number 1. But what else canceled? Yes, the x canceled. So what stays behind? What didn't cancel? It's important. You have to process that you still have an x minus 4, x plus 3. Same thing here. What canceled? X minus 4, right? What didn't cancel? X, x plus 3. Okay, and over here, same thing. X plus 3 cancels, but what we really are concerned about is what didn't cancel. And I'm going to run out of space here, so I'm going to put a cx and an x minus 4. You got to organize this, okay? But honestly, before you organize it, quite a bit of foiling. You got some foiling. I would not suggest that you distribute the letter A until after you do the foiling. So if you needed to see that, it's going to be A, x squared minus x minus 12. It's going to be B. It's supposed to be a B times x squared plus 3x. That's just x squared. There's no negative there. And then C, x squared minus 4x. Okay, at this point, you should feel comfortable that you can put all the x squareds together, all the x's together, and technically the constants. Okay, so A, B, and C all have an x squared. So minus 4cx. Okay, so all the x's. We have a minus ax, we have a plus 3b, a plus 3bx, and a minus 4cx. Okay, just in case you missed it, I'm doing the distributive property. And of course, once I do the distributive property, I'm able to rearrange and organize these terms. There's a few more terms. Actually, there's one more term. It's the minus 12a. Minus 12a. There's no other term that's like it. Note, there's no other term that's like that. Every other term has an x. Organize, factor. Maybe you skipped to this step. That's fine. I can see students that already can see that we're going to be left with a plus b plus c. Now, I would factor out a positive x. All right, factor out a positive x and let the negative signs be part of the a, b, and c. So we're left with a negative a, we're left with a 3b, we're left with a minus 4c. That's what happens when you factor out an x. Nothing factors, nothing changes with minus 12a. All right, we're there. We're at my favorite step. You have to equate the terms. Remember how the question went? What's in front of x squared? What's in front of x squared? A plus b plus c. So what's in front of x squared on the other side of the equation? What's in front of x squared on the other side of the equation? 0. 0 is in front of x squared. That means that a plus b plus c is equal to 0. Keep equating. Keep writing out your system. You're making a system. What's in front of x? What's in front of x on both sides of the equation? 0. Okay, so our second equation is negative a, 3b, and minus 4c. That's also equal to 0. It's fine. You can have an equation, two equations equal to 0. They're different equations. Okay, now the only one that kind of has a little bit of flavor to it is the constant. There's a 1 on the left side of the equation, so that means the constant has to equal 1. How do you write that as an equation? Well, you would write negative 12a equals 1. Okay, now you'll notice that I left my system kind of ready for, at least most students would prefer to have this ready for a matrix method. And so that last equation needs to have a couple placeholders, just a couple zeros, but those are different zeros. Those are for b and c. I would put this in your calculator. Okay, so I put in my calculator the coefficients of the first matrix, which are just 1, or the first equation, which is just 1, 1, 1, negative 1, 3, negative 4, and negative 12, but 0, 0. So we're putting those numbers in. Put in your B matrix. Of course, we'll do the ever famous A inverse times B. And out pops a mess. Okay, now this is why we've been prepping for this, because that mess we'd like to see in fraction form. That's much better. So in fraction form, we actually get nothing more than a little negative 1/12, a 1/28, and 1/21. Okay, now those three values, those actually would be the numerators of our fractions. But I'll tell you, it's a little strange to put a fraction into a fraction. So instead of writing 1/12, I have a couple options. Probably, honestly, the best option, it's negative 1/12. Probably the best option is to just write negative 1/12 right beside a 1 over x. Okay, and then I can write a 1/21. I can write a 1/21 right beside 1 over x minus 4. And then I can write the 1/28. I thought something looked funny. So 1/28, and then the 1/21 we'll put over x plus 3. You know, this does bring up a question normally a student would ask. What if you set up the template kind of backwards? You know, what if your A was my B, was her C? Well, it doesn't matter. You're still going to get negative 1/12 going with 1 over x. You're still going to get 1/28 going with 1 over x minus 4. and you're still going to get 1/21 with 1/x plus 3. So it doesn't matter what order it's in. Okay. Just technically, if you're saying, could I have written this as something like maybe -1/12x? Yes. And yes, you could have kind of combined it a little bit. There's a reason that I left it in the first form, and it'll be for calculus next year, but it's not a big deal. You certainly could present it the way I wrote it in the second line, just combining those fractions a little bit. So, what do you think? Partial fraction decomposition? Are you ready to try some on your own? Okay, well, you know, if you've ever wanted a short homework assignment, here it is. It's just 3 problems. But what types of problems are they? Yeah, it's these partial fraction decomposition problems. So they take a little bit of time, a little work, but I'm confident that you're ready to roll. All right, see you next time.